Use simple example for curl operation. Simple example. Anyway, this example is available in YouTube. Just I'll explain and I will share you the related videos. Okay. Now, இது போல ஒரு சேனல் இருக்குங்க சார். இது போல வந்து ஒரு சேனல் இருக்கு. இதுல வந்து வாட்டர் வந்து பாஸ் ஆகுது. சே ஃபார் எக்ஸாம்பிள் லெஃப்ட் டு ரைட் வாட்டர் போகுதுன்னு வச்சுங்க. ஃபார் எக்ஸாம்பிள் வாட்டர் போகுது. பொழுது மிடில் வாட்டர் உடைய ஸ்பீடு வந்து கொஞ்சம் அதிகமாக இருக்கும். ஏன்னா டிஸ்டர்பன்ஸ் இதெல்லாம் கம்மி. ஸோ அதனால மிடில் கொஞ்சம் ஸ்பீடு அதிகமாக இருக்கும். அகெயின் எட்ஜில் வர கொஞ்சம் வாட்டர் ஸ்பீடு வந்து கம்மியாகும். ஜென்ரலாக நீங்கள் ஒரு சேனல் இது போல் எடுத்துக்கினேன் அது வழியாக நீங்கள் வாட்டர் பாஸ் பண்ணுறீங்க அப்படின்னா மிடில் போகிற வாட்டருக்கு கொஞ்சம் வெலாசிட்டி அதிகமாக இருக்கும், சைடில் வர்றதுக்கு வெலாசிட்டி கம்மியாக இருக்கும். ஓகே, இதுதான் வந்து ஜென்ரல் ஐடியா. இப்போ again whether this water is having rotational nature or not, okay, whether the water flow is having a rotational nature or not, அதான் வந்து நம்ம ஐடென்டிஃபை பண்ணணும். அதுக்கு முன்னாடி சப்போஸ் இது போல ஒரு சேனல் இருக்கு, பட் அதுல somehow water flow is always uniform irrespective of either in the middle or at the surfaces, near to surfaces, the water flow is uniform. So again here it is very clear, it is not having any rotational nature, it's simply going linearly, it is going. But here the rotational nature is present, but it is not directly visible, but here the rotational nature is present. Okay, so how the rotational nature is present? To identify the rotational nature of this water flow, okay, you take some object. Okay, for example, I take some flower, I am putting it here. Now you tell me what will happen once if I put the flower here. What will happen? Either the flower rotate avuma avada. I am putting some flower there, that too here. Okay, that too here. Now in which direction it will rotate? It is very clear. Okay, here the force is more, here the force is less. Definitely it will rotate in this direction. Definitely it will rotate in this direction. Okay, so again I can place anywhere. I can exactly place at the middle, I can place near to the edge or surface. But once if I place it in the middle, definitely it will rotate in this direction. Definitely it will rotate in this direction. Again, the amount of rotation itself depends on where you are actually placing your flower. Okay, if you place your flower here, there may not be any rotation. Okay, simply it will be going. Or otherwise, if you place here, maybe you will get some rotation. Again, it may increase and then finally it may decrease. What is happening? Definitely there will be rotation. That rotation also depends on the position where you are placing. Okay, your position. Okay, and similarly, if you are putting same flower here, in which direction it will rotate? It will rotate in this direction. It will rotate in this direction. Anyway, this is the plane. This all is a plane, and finally your del cross will be in which direction? Your del cross will be in the perpendicular direction to that plane. Okay, perpendicular direction. Definitely your del cross will be perpendicular direction, because already I told you this is one vector, this is another vector, it will form a plane. Even if it is a space vector, it will form a plane in that space. Okay, it is a plane vector. Okay, once if you take a cross product, definitely your final result will be in a perpendicular to the plane of del and f. Plane of del and f. Okay, now finally your vector will be in a perpendicular direction. Okay, so again direction is fixed. Either it can go upward, there are two perpendicular directions possible, or it can go downwards. Okay, this also possible. Okay, because both are perpendicular to the plane. Okay, then or otherwise for clarity I can draw here itself. Okay, see for a perpendicular thing, for this one the vector will be like this, And again for this one, the vector will be like this. And please, here also you have to follow the right hand rule. Okay, you please see here what is the rotation. You place your right hand in such a way that your fingers are curved in this way. Definitely your thumb indicate this direction. Or if you are placing your finger in such a way the curve is going in this way, then definitely your thumb will point out downward direction. Then what's happening? If the flower rotates in the anti-clockwise direction, you are getting a vector in upward direction, say positive direction. Okay, if del cross f something is positive, means what's that? Your vector is rotating. Your vector is rotating in the anti-clockwise direction. That I already explained. Okay, or if it is rotating in the clockwise direction, definitely your result will be in a bottom direction, downward direction. Okay, negative direction. Then what is the magnitude of this? Okay, what is the magnitude of this? Anyway, we have identified the direction. Then what is the magnitude of? Magnitude depends on how fast it is rotating. Okay, if there is no rotation, okay, you see the magnitude goes like this. Your magnitude may be 0. Okay, your magnitude may be 0, or it may increase slowly, or it may go to some maximum, then it may decrease and it may 0. Like this it goes on. Okay, depending on the place where you are putting your flower, uh, the magnitude of rotation, the speed of the rotation. Okay, see that magnitude of this vector is exactly as equal to the speed of the vector. Okay, speed of how fast it is rotating. Okay, the rotation speed also depends on the position of the flower. Okay, I will share you the related video of this curl topic. Okay, once we go through that, they will give you the mathematical equation and everything. Once again you can see the physically what is happening, and again what is the mathematics behind that, and finally you will understand what is actually called del cross f. Okay, next what is there are two theorems. One is Stokes theorem and another one is divergence theorem. Okay, Stokes theorem, and another one is divergence theorem. And what is actually the Stokes theorem is doing? Okay, the Stokes theorem connects the relation between line integral, and the surface integral. See, what is the idea here? You are having some field, let it be electric or magnetic field. Okay, electric or magnetic field. You calculate the line integral, or otherwise you calculate the surface integral, but with some modification. Okay, they may apply some del operator. Okay, then you calculate the surface integral. Both are same. Okay, you are having some field, you calculate the line integral directly. You apply some del operation, then you find out surface integral. Both are same. That is the idea of the Stokes theorem. Okay, then what is the problem here? Here is line, either the line integral is open line integral or closed line. You have to be careful there. Either your line integral is open line or closed line, and your surface is a open surface or closed surface. Okay, whenever integral is there, they will put like this. That means what? Something is closed. If it is a line integral, closed line integral. If it is a surface integral, closed surface integral. If it is a surface integral, closed surface integral. Okay, can you put like this and say closed volume integral? Anybody? See, volume itself by nature it's always closed. So don't put, whenever there is a volume, don't put any closed things like that, because volume itself is always closed one. The surface may be may or may not be closed. Okay, surface may or may not be closed. Line may or may not be open or may be closed. Okay, you have to be a little bit careful with this notation. Okay, whenever I'm putting some circle means that is like a closed. If it is a line integral, closed line integral. If it is a surface integral, closed surface integral. Okay, then my question is with what line you can make a surface? I want to make a surface. Okay, I want to make some surface. With what? With open line, can you make a surface with open line? This is like a open line. Okay, this is like a open line. With open line, you cannot form surface. Simply that is a line. Okay, open line. But with closed line, you can make a surface. Okay, with the closed line, you can make a surface, but you can make both open or closed surface, but for simplicity, with a closed line we will form a open surface. Okay, with a closed line we will form a open surface. Okay, so see, say this is some kind of structure. Okay, and if you see here clearly, this one is like a closed line. Okay, in this process, this is like a closed line. In this process you have formed some surface. Okay, these are all like a surface. Okay, you are having some surface. The surface has been formed by some closed lines. Okay, closed line. Okay, so uh, what is this Stokes theorem tells? It relates the closed line integral and open surface, closed line to open surface. Okay, please note down very clearly, because this is very important. They are generally in the exam they are confusing with this, either open or closed, like that. Anyway, everyone knows the formula, but you should be very careful and very thorough, either it is closed or open. Okay, the Stokes theorem deals about the relation between closed line and open surface. Closed line and open surface. Okay, please note down, very important. What is the Stokes theorem? It gives a relation between closed line integral and open surface integral. Why not open line? With open line you cannot make a surface. Okay, with open line you cannot make a surface. Only with the closed line you can make a surface. Okay, that too in this case that is open surface. Okay, this is a relation between Stokes theorem means always the relation between closed line integral and open surface integral. Okay, then what is the actual formula? Okay, you take any vector. Okay, in this case now I take simply a f vector. Okay, integration dl. Okay, again we have mentioned closed line integral. Okay, closed line integral f dot dl. Please be careful with this notation, f dot dl. That means what, sir? F itself is a vector, dl is another vector. If you take dot product you will get the effective result. Okay, and first of all I will write the equation, then I will discuss one by one meaning of this. Okay, in general the Stokes theorem relates the closed line integral with open surface, that to del cross f. Okay, del cross f dot ds vector. Okay, del cross f, because f itself is a vector. Once if we take del operator, again still it will be a vector. Again ds bar is another vector. Okay, surface vector. And finally vector dot product is what? Something scalar. Then again you can do your integration. Okay, similarly here also vector dot product with vector is a scalar, then you can do the integration operation. And again here what is the observation? You are connecting the closed line with the open surface. This is the open surface. That's why I did not put any circle like this here. Please be careful with this notation. In the exam they will confuse you with this. They will give you the Stokes theorem with this only with the help of circle. They will vary the option. In some option they will put the circle, in some option they will not put. Okay, so please be careful about it. Next, so what is the idea? It is the connection between the closed line integral and open surface integral. Again please be careful. We have made some relationship, either this is following that unit relationship. We'll quickly see. Okay, we'll quickly see. Anyway, I have taken some random field. I don't know what is the value of the field. Okay, value of the field. I have taken some field. Okay, then I am doing some integration. Okay, I don't know what is the, because I don't know what is the nature of the field. It may be electric field or magnetic field. Definitely there is some field. Okay, it will have some unit. Let it be there. Okay, that is the unit of the field. I don't know what is the unit. Okay, that is simply unit. Once if you do integration, what you are doing? Integration is a simple kind of multiplication. Okay, integration is like a multiplication. Okay, if the line is not regular, if the line is in the regular fashion, you can take ordinary multiplication. Okay, because integration itself is a calculating some area concept like that. Or otherwise what will be the unit? Just like a multiplication with the dl. What is the unit of dl? Okay, anyway, integral dl is length. Unit of length is meter. Okay, now my final unit is unit into meter. Okay, next you calculate. First, you are calculating del cross f. I clearly told in the previous session what is del. It is a differentiation operation. It is a differentiation operation. You know, whenever there is differentiation of something divided with respect to x, that means space operator. These are all called space operator. Once if it is a space operator, what will come? Unit divided by meter. We don't know what is that unit, but once if you apply del cross f, something divided by meter, because this is a differentiation. The differentiation numerator, you will have some function. We don't know the nature of the function. That's why I'm taking simply as a unit divided by meter. And again, what is the integral ds is, yes, that is some surface. You know, surface means unit is meter square. Once if we cancel out meter and this one, finally you are getting unit into meter in left hand side and unit into meter on the right hand side. So what I am telling here, see, you take any equation that has to follow the unit relationship. You take any equation in any subject, almost that has to follow the unit relationship. Why? Because see, you should not have confusion in the future whether surface will come or volume will come. That kind of confusion should not be there. Okay, whether surface or volume, like that confusion should not be there. Because see, with this unit concept, you can match. If at all you are having some confusion whether ds will come or dv will come, once if you do this, then finally you can conclude, okay, this is ds only. That's why unit, you should know the unit relationship for all the equations. Okay, so again, so somehow we have proved that this equation is true. And one more thing is, this is like a closed line integral and this is like a open surface integral. Okay, then how to calculate this line integral? First we will see how to calculate the line integral given a situation. See, they given is some vector. Okay, they given is some vector. Then how to calculate the line integral? Then we will see what is the closed line integral. Okay, first of all we will see what is a line integral. Okay, see, if my line is going in this way, if my field is going in this way, this is my field. Okay, this is my field. Okay, then I am interested to calculate the line integral along this path. Okay, I am also interested to calculate the line integral along this path. So what will happen? This is the direction of the field. Okay, this is the direction of the field. Okay, I am also interested to calculate my field. What is the field effect of the field in this direction? Already field is there. Now I want to calculate what is the effect of the field in the direction. Definitely your field and your direction of interest is same. Your field and the direction of interest is same. So what will happen once if you take dot product of these two? Definitely you will get some maximum number. Okay, that is the idea of the dot product. Once if you make dot product of one vector with another with the same vector, okay, in the same direction, definitely you will get some maximum number. Okay, see, if you are having a vector, if you make dot product to the a vector, what will happen? You will get a square, some kind of maximum number you will get. Similarly, in this case, once if your direction of interest and the field direction is same, definitely you will get a maximum value. Definitely you will get a maximum value. Okay, then this is the simple case. Or otherwise, if the situation is like this, okay, the situation is like this. The field is going in this direction, but I am interested in some other direction. Okay, I am interested in some other direction. Say this, in this direction I am taking dl. Okay, dl. Now my field and the direction of interest is exactly perpendicular. My field and the direction of interest is exactly perpendicular. Now once if you make dot product of these two, once they are exactly perpendicular, what will be the dot product? The dot product is 0. What is the meaning of that? Okay, what is the meaning of that? See, here the field is in this direction, say electric field. The field is in this direction. Okay, now I am moving in this direction. What is the effect of this field on me? There will be no effect. Okay, there will be no effect. See, I am moving in this direction. Field is going exactly perpendicular to me, so it will not affect me. So in a field concept, it will not affect me. That means once if it is not affecting you, what is the interrelationship between your direction and field? That is 0. That is 0. This is the concept of the line integral. This is the concept of the line integral. Now the question comes, suppose if it is a closed integral, what happens? Okay, see, once if it is a closed integral, same, this is the closed line of interest. This is my closed line of interest. Again, even if it is a closed line, you have to follow some notation. Either you have to close the line in the anti-clockwise manner or in the clockwise manner. Any one of the notation you have to follow, but it is better to always follow this one, anti-clockwise manner. Okay, then what happens if your field is going in this way? See, again, if your field is going in this way, see, your field is going in this way. Now I want to see, I have taken some closed line. Okay, what is the meaning of here? Initially I am standing here. Already field is going in this direction. Now I am moving in this way and I am going here, coming back. Finally I am reached my starting position. That is like a closed line integral. Now what is the effect of field on me? What is the effect of field on me? That is the idea of this integral. What is the effect of field on me? See, once if you are going in this way, you and field are in the same direction. Definitely you will get some number value, because both are you both are in same direction. You will get a plus n. But once if you go in this way, field and your direction is exactly what's the opposite. Once if you go in this way, see, in this way, you are going perpendicular to the field. Just now I told, once if you go perpendicular to the field, the effect of field on you is 0. Okay, effect of field on you is 0. And again, in this case, what happens? In this case, field is going in one direction, say positive x direction. You are going in the opposite direction. You are completely opposite. See, you are going against the field. Okay, you are going against the field. Already field is going in this direction. If you are going in this direction, both are in opposite direction. Okay, that means what? So you will get minus number, negative number you will get. Okay, see, if some vectors are opposite to each other, okay, there are two vectors, they are exactly opposite to each other in direction, then definitely you will get what's minus n. And then finally you are